Good afternoon. Okay, today we're doing dividing polynomials. I believe this will be the last video on polynomials in this unit. So we're doing two things. We're taking a polynomial and we're going to divide it with a monomial. And then we're going to take a polynomial and divide by another polynomial. But I'll put a small p here because the polynomial that you're dividing by is going to be shorter than the polynomial that you're dividing with. Okay, dividing is the opposite operation of multiplication, so we're not learning something brand new because we've already multiplied polynomials, and so we're just doing the reverse. So you will see familiar patterns. You will sense that the processes we're doing are you've done in the past, and that's because you'll just be doing those same processes backwards. So first, polynomial divided by a monomial. So I'll start with a simple binomial. Let's take 4x squared y plus 6x squared y squared and divide it by a monomial 2x squared y. Okay, we can write it using this division symbol, or I personally prefer writing it as a fraction, like this. It's the same problem, but I like looking at it like this, and get to work. So I'm going to show you the step-by-step way first, and then after that you can choose to do some of it in your head. The first step to taking a polynomial and dividing by a monomial is find the GCF of the polynomial. So the GCF here is 2x squared y, and the leftover is 2, just 2, plus 3y. And you'll see that the denominator is the same as the GCF that we just took out of this polynomial, so I can cancel completely that GCF with the denominator, and my resulting quotient is 2 plus 3y. Okay, so again, the process was you take out GCF, then you cancel the GCF with the denominator, if possible, and then whatever your leftover is your answer, is the answer to the division problem. To check this, take your divisor, multiply it with your answer, and see if you get what you started with. And if you do, which we do, then you're all right. Okay, let's try this with trinomial. Okay, we have this trinomial divided by I'm just making this on the spot, so I'm not actually sure what's going to happen. Okay, the GCF in the top is 12 x cubed y squared. Leftover is one minus, oh sorry, the GCF is not 12. GCF is 6, yeah, 6 x cubed y squared. So the leftover in the first term is 2. Second term minus 3xy plus 4y to the third. This is the denominator. Okay, now I see if I can cancel the GCF with the denominator. I cancel as much as possible. I can cancel the y squareds, the x cubes, and not the 18 entirely, but 6 does go into 18 3 times. So I'm left with a 3 down there. So this quotient will end up being a fraction because of that leftover 3. Okay, so you may or may not be left with something in the denominator. In the first example, obviously, it canceled completely, so no more fraction. In this one, it did not cancel completely, so we still have a fraction with a less complicated looking denominator. And I want to explain why we're allowed to cancel here. Let's pretend A is the GCF that we already took out. B plus C is the leftover. And let's pretend the denominator is A is identical to the GCF. The reason you can cancel this A with this A is because this is the same thing as A over A times B plus C. That's definition of division. I can rewrite this like this. And here it's clear why you can cancel the A's, because this is equal to 1. Okay? But if you understand that, you don't have to write this step. You can just cancel the A's directly. Okay? So those are your two examples of taking a polynomial and dividing by a monomial. Now we're going to do a poly divided by a shorter poly. Well, actually, in this case, it's not a shorter poly. It's a binomial divided by a binomial. Okay, and I'm going to write it as a fraction. Okay. Now, when you have a fraction, focus on the polynomial in the numerator. It's highly likely that the polynomial in the numerator is factorable. And in this case, it's a difference of squares. So that factors, so I should factor it if it's a difference of squares, x plus 2y, x minus 2y. And the denominator is x plus 2y. So I have a common factor here. I have an x plus 2y up here and an x plus 2y down here, so I can cancel it completely. And the leftover is x minus 2y. That is my answer. That is what x squared minus 4y squared divided by x plus 2y is. Okay, here's another one. X squared plus 2x minus 35 divided by x minus 5. Trinomial might have winners. It does. The winners are 7 and negative 5. So this is the factorization. I have a common factor, a big GCF of x minus 5. Actually, this was a big GCF too. Leaving me with x plus 7. Okay, let's try a binomial this time. Okay, x cubed minus y cubed divided by x minus y. It might be tempting, I'm sure it is tempting, to write this or this as your answer, but they would both be wrong. Because if you FOIL this times x minus y to check and see if you're right, or FOIL this with x minus y to check and see if you're right, you will not get x cubed minus y cubed. You'll get something much messier and much longer. You should by now be able to recognize that this is a pattern, a polynomial pattern that I've given you. It is difference of cubes. And since difference of cubes has a factoring pattern of x minus y, lo and behold, it's right there, times x squared plus xy plus y squared, then that must mean that if you divide x cubed minus y cubed by x minus y, the result would be this factor. So this is a case where memorization comes to your aid, because it would be very hard to figure this out, this trinomial out, if you didn't have the pattern memorized. The process of finding out this by hand on your own would be long and arduous. So you really need to memorize those patterns or have them handy. Difference of cubes, also sum of cubes, and of course difference of squares, which by now everybody knows. Okay, so that's polynomial divided by polynomial. Factor, cancel. Factor, cancel. Polynomial divided by monomial. Factor, cancel. Factor, cancel as much as you can. Okay, so there's a pattern here. Factor, cancel, factor, cancel. All right, have a good day. See you next time.